If we look at the sequence 1, 2, 4, 7, 11 and try to predict the next number in the sequence, there's a technique we can use. Before I do that, you should pause and attempt to find the next number, the most probable next number in this sequence. Okay, the technique is simply to see, and you probably did this if you looked at the problem. From 1 to 2 we change by 1, then we change by 2, then we add 3, then we add 4. Now we can formalize the process, although we see that next we would probably add 5 and get 16. If we formalize the process, see that there's a difference of 1 between 1 and 2. From 2 to 4 the difference is 2, then the difference is 3, then the difference is 4. It's very clear that the next member in this sequence is probably 5, so that if we want the next number in the sequence here, we can say that, well, we're going to add 5 to 11 and get 16, and obviously we can continue this as far as we like. I'm going to go ahead and remove those 3 dots so that this doesn't end up being overly confusing. We could have gone, incidentally, to one more step. The change here is 1 each time. And of course that's obvious. In this case it might not always be obvious that you always have the same change if the numbers are larger, if the gaps between these numbers are much larger and the gaps between these are large. Okay, let's try to apply the same technique to this sequence. Okay, from 2 to 9 the difference is 7. From 9 to 28 the difference is 19. From 28 to 65 we can subtract. We see that the difference is 37. And from 65 to 126 the difference is 61. Is it obvious what's going on with this sequence? Probably not. So let's take another step. The difference here is 12. The difference from 19 to 37 is 18. From 37 to 61 the difference is 24. Now at this point it might be obvious what's going on, but if it isn't, we can go one more step and see that the difference here is 6 and the difference here is 6. Now if we try to build the sequence back up, we can do that one step at a time. The next element here is going to be 6, so that if we add the 6 we're going to get a 30 here. So that the next element in this sequence will be 30, and then the difference between 61 and the next element we would presume to be 30, telling us that the next number in this sequence would be 91, so that if the difference in this sequence is 91, the next number has to be 126 plus 91, which is going to be, I believe, 217. So this illustrates the method of what we call successive differences in building up the members of a sequence. If you can get down to a constant difference, then you can easily build the sequence back up. And of course, this assumes that the sequence does have some kind of predictable behavior, and a behavior that's actually predictable by this method. This is inductive. We aren't sure of the result, but this is the most probable result we can obtain.